the map that I just handed out is on Maryvale. Now you'll notice there is two maps, okay? You've got the photo map and the topographical map. Now firstly, you can tell me what's the difference between the orthophoto and the topographic. What's the biggest difference here? The biggest difference between the two maps. Yes, Rebecca?
In the orthophoto map has a scale of 1 to 10,000.
Yes.
And then the topographic has a scale of 1 to 50,000.
Perfect. Okay, so the first thing that we look for, okay, is of course the scales. The orthophoto map you will always notice, especially in South Africa, that has a map of 1 to 10,000 of course. The topographical map has a scale of 1 to 50,000. Right, so firstly guys, the lesson we're going to do today is of course gradient, where we're going to focus on the gradient specifically, what's the importance of the gradient, and then why do we need to do it. Right. Afrikaans is all after I'm done, I promise you I'll explain it to you guys later. Okay? So just stick with me. Yeah, so the lesson objective is of course define what a gradient is in Mapwork, explain the formula for calculating the gradient, accurately calculate the gradient using a compass, and so forth and so forth. Right, so first things first. I'm going to chop and change a lot between maps, right? So I'm firstly going to use a map that is not part of the maps that I added out, because I'm going to show you, I'm going to explain it, and then we will look at the map that I handed out to you guys, and then there's going to be a few exercises that you're going to need to do from that map. Alright, so firstly, when we look at a map, the first thing that we notice is of course, yes, I know it's it's not very dark and so forth, but we notice contour lines. I'm just going to draw contour lines there, just so that it represents something. Right, and then in certain areas we will notice that the contour lines moves further apart. Okay, so when we look at contour lines, what is very important to understand about the spacing of the contour lines? What do we know about the spacing of the contour lines? What do we know about the spacing of the contour lines? Any of you know? Is that?
As die contour lyn nader aan mekaar is, beteken dit is meer styl.
Okay.
Ver mekaar as dit gelyk.
Alright, so when the contour lines are closer together, it means that the area is much steeper. Eh? And when the contour lines are further apart, it means that the area is less steep. So if you look at these ones, you see the spacing in between gets more as we go out. Okay? So that means as we go downwards, that means that this is a hill, and as we go downwards, it gets less steep and less steep and less steep. You see that? Right? So, number 6, of course, from number 6 is downwards, becomes less steep. So that at number 6, that will be then on top of the hill in this case. Right, so but in between we have things that's called spot heights. Then there's of course 4 ways we can know height above sea level on a map, of course. The first one is contour lines, the second one is what? Alright, trigonometrical beacon. What's the third one? I just said it. What's the third one? What's this? What is that? Spotlight, eh? Afrikaans punthoogte, and of course in English it is spotlight. So that is the ones that we regularly use to get height above sea level, of course. And then what we want to do when we look at gradients, we need to know why gradients are important. Of course, let's say for instance if we do planning of a city or a town and so forth, it's important to do planning regarding the height of the hills, and let's say for instance the layout of the land itself, because it's important to understand where we're going to build houses and where we're going to not build houses and so forth. Okay? That's very important to understand, because the steeper an area is, the less likely we are to build there. Like for instance, our mountain here on the outside, we're not going to build a house on this mountain or on the side of the mountain. Who can tell me why? Why won't we build a house there? Hoekom gaan ons die huis bou? Sien jy maar? Dis baie stil, and what happens if the area is very steep? What happens then? bit. But if you want to build a house there, do you think it's going to be more expensive or less expensive than building a house on flat ground? More expensive. Why? Who got it?
They need to use more technology to like
Right? Maybe not to say technology, but let's say, for instance, if we have to build a house against a very steep hill, the foundation needs to be stronger, and the more material they have to put in, or move in more material and stuff like that. Okay, so in this case, that is one of the reasons. So when we look at the hill, of course, we can notice that it's either going to be very steep, or it can be less steep, or it can be horizontal in this case. Okay? So let's quickly look at a specific area that I've highlighted for you guys. Alright, so in this case, guys, we're going to focus on the spot here. I'm just going to zoom it in for you. The one spot that we're going to look at is, of course, block height. And the second spot, so the height above sea level, in this case, that specific spot height is 1706. And the other one that we're going to look at is spot height 1656. Okay, those are the two that we're going to look at. So I drew a picture on the board for you guys just so that you can see, right? So that is now the height of the two spot heights that we want. Okay, but when we talk about the gradient follows a formula. Now the formula for the gradient is, of course, gradient is equal to vertical height, or VI, VH, over horizontal distance, HD, horizontal distance. Okay, that is your formula of how you are going to calculate the gradient in this case. So, because we need to see the gradient in order to say if the yield is very steep or if it's not as steep. Okay, so first things first, let's look at this. Let me just remove this quickly, then you can see that work properly. Alright. The first thing that we need to look at is the two height indicators here. Because when we do a gradient, there is two things we need to look at. The first one is, of course, the height, and the second one is the distance between the 2 points. Okay? So at that stage, we have our gradient. So this is basically where mathematics start to play a role, and in geography. Okay, but it's not so important that you must. I mean, it's not important to know mathematics, but let's just understand that principle. Right. So first things first. We can see what is the highest point in this case. Is spot height 1706. So what you write is you write there 1706. And the bottom height is what? What is it going to be the bottom height? 1656. Okay? So now you've got the total height, or the two height indicators that we want. So you must calculate the differences between the two height indicators. Okay? How do we do that? You just take 1706 minus 1656. And that will give you what? 1706 minus 1656. That's going to give you 50 meters. Okay? But we know, because we are looking at contour lines, we know the height above sea level will always be in meters. It will never be in centimeters. Okay? Right. Now, the second thing that we need to look at is the distance. What is the distance from that point to that point? Okay? But because we are working on a map, we know that it's in 2 dimensions. Okay? Map is 2 dimensions. So of course, that distance we're going to measure is from that point to that point. That will give us the distance, of the distance in this case. So, let me go back to the map, and we can quickly measure the distance. In this case, let me just use this one, or maybe this one. It's not going to be accurate because the distance on this one is of course different from a normal ruler, but I'm just going to use it for a reference in this case. Okay? So you put it on the 2 spot heights, of course. There's a spot height point there, and there's a point there. That is the distance that you need to calculate. Okay? So in this case, put it there. and that point there. So let's say, for instance, in this case, it is 32 centimeters. 32 centimeters. Okay. Just for reference, it's not going to be that. You can check on your maps, that will be different, but that's now the way we measure it, right? So in this case, we say from that point to that point is 32 centimeters. Okay, now we go back to our 32 centimeters. Okay, but very important to understand, this 32 centimeters, is this 32 centimeters real life or is it map distance? It is still map distance, eh? So we need to convert this to real life distance. Okay, guys, we've done distance calculations many times, eh? That's the first thing that we looked at, and you guys did it, you did last year, grade 9, and of course in grade 8 as well. So let's quickly focus on real life distance again. So distance, we know that it's 32 centimeters. How do we get it to real life distance? You times it by the scale. What is the scale in this case?
50,000.
Is it a topographical map or orthophoto map? It's the orthophoto, so what is the map scale? 1 to 10,000 there. So in this case, it is 1 to 10,000. So 32 centimeters, it's going to be times 10, so 0, 0, 0, 0. Of course, we keep it in centimeters. Now, we've got the centimeters, we've got the height distance. Let me just get back to that. The height is 50 meters, right? Let me just get back to this one. So we know the height, vertical height is 50 meters, and the distance we need to calculate. So do we usually measure in centimeters or do we convert it to meters and kilometers? We convert it because it's just easier to use, right? But we can see that the vertical height is already in meters. And we know that when we have one unit, both units must be the same. So we can't use, let's say, for instance, centimeters. The one unit is centimeters and the other one is meters, right? We have to convert the one so that it's equal to the other one, right? So let's quickly convert then 32, well, it's going to be 320,000 centimeters. Let's convert it to meters. How do you convert it to meters? What do we do?
Divide by 100.
Okay, divide by 100. Eh? We know to go from something small to something big, we divide. Eh? So divide from centimeters to meters, divide by 100. In this case, 1, 2. So we've got that. Eh? So in this case, it is 3,200 meters. The horizontal distance. Okay. Is both of them the same units now?
Yes.
Same units. Can we do the calculation then?
Yes.
Right, so gradient. The gradient is what? Vertical over horizontal, eh? Okay. So, sorry. Right, so gradient in this case, I'm just going to make a gradient is equal, what is the vertical height? 50, okay? Divided by 3,200. 3,200 meters, of course. Both of them is meters. Just write the unit down. It's just easier to understand what the unit is there if it's in that. Okay? So what do we do now, guys, is we convert it. Right, but what I always tell you, what do we do in order to get to gradient? What we want the gradient to be, we want to something, eh? Or something to 1. That is how a gradient works. Eh? So how do we get it? What do we do? We've got the largest one and the smallest one. What do we take to make that 1, 1? What do we do in order to make this one of these values 1? We always take the smallest value, okay? We always take the smallest value. What do we do with the smallest value? Divided by itself to get 1. Okay? So what do? Is you take 50 divided by 50. That will give you 1. And then we take 3,200 meters and also divided by 50. What will that give you? Do the calculation quickly. So you take 3,200 meters divided by 50, and that will give you 64. Next, 64. So in this case, guys, in this case, we will note, you will notice something. The gradient in this case is 1 to 64. What does that mean? It means for every 64 meters that you move horizontally, you are going up 1 meter vertically. Okay?
So meneer,
Yes?
ek gaan weet ons net in meter.
Alternate meter, yeah. Always just meter, because that is unit of the contour lines. Height above sea level is always meters. Okay? Okay? Right, so let's go back to the first one, guys. Now we will notice, because I mean 50 meters. 50 meters for 320, it's not 32 centimeters in real life. What was that? That was, let's say, 3,200 meters. That is not very steep, né? Not very steep. Okay, so, yeah. Are you guys happy?
Yes.
Right. Okay, so what I want you to do now is just go to your pages, guys, go to your maps, look at block E4. Take spotlight 1411. And block E5 is spotlight 1308. Go to those two spotlights. So I'm just going to repeat it again. Block E4 and block E5. The spotlight 1411 and 1308. 1308. Yeah, I kind of feel it. Right? Spotlight 1308. Then you guys can just do the gradient calculation for those 2 points. Okay? Just follow the steps that I showed you now guys, and just practice that. Of course, the more you practice, the easier it becomes.
I think we have different maps.
What do you mean?
Yes. There's no spot.
Very well.
So can I use it?
E4, we'll go to E4 copy.
Graphic maps.
Yes.
Yes, topographical map. So in this case, guys, you're going to use the topographical map. Of course, that's now going to be the map. The map scale is going to be different. It's going to be 1 to 50,000. So when you do your calculations, just do it accordingly there. Okay. Right. So yes, topographical map. Do you see it there?
Yes.
Okay. Good. Yes.